Today we will be solving this problem. If we take the square root of x plus 28, add it to the square root of x, and the result is 14, what is x? So, can you solve it? I know we can take the square root of x on the right side, and then square both sides to eventually remove the square root, and then solve for x. But today, we will be using a different approach, just for fun, involving radical manipulation. I won't claim it will be a faster technique than squaring both sides, maybe it is, but I think it's good to explore alternative methods to broaden our problem-solving ability. Sometimes, thinking outside the box helps us see patterns or strategies we might have missed. So, what if we multiply and divide the left-hand side by the conjugate of this thing, which is the square root of x plus 28 minus the square root of x? Let us simplify the numerator first. Using the identity for the difference of squares, we know that the product of a plus b and a minus b equals a squared minus b squared. In this case, a is the square root of x plus 28, and b is the square root of x. So, squaring a gives us x plus 28, and squaring b gives us x. Subtracting the two, we get x plus 28 minus x, which simplifies to 28. This means the numerator now becomes 28. So, the entire left-hand side simplifies to 28 divided by the square root of x plus 28 minus the square root of x, and this thing equals 14. Now, we take this denominator here and take 14 here to get the square root of x plus 28 minus the square root of x equals 28 over 14, or 2. Awesome! Now, here comes the magic. Subtract this equation with this one like this. So, here this will get cancelled out, and we are left with 2 times the square root of x equals 12, and thus the square root of x equals 6. So, squaring both sides gives us x equals 36, and that's it. Wolfram Alpha also confirms the solution. Isn't this cool? So good!